Hello everyone, my name is Ever Barbero, and today I'd like to do an example about predefined fields, to supplement my textbook, Finite Element Analysis of Composite Materials using Abaqus. In this example, we show you how to apply a predefined field. A common use of a predefined field is to apply temperature to a region of a structure, during structural analysis, to calculate thermal stresses and deformations. As bonus, you will learn how to visualize the whole structure from a quarter model FEA, using the mirror technique. To create the part, we sketch a rectangle. Next, we enter the material properties for one of the laminas. Including the coefficient of thermal expansions, CTE, in 3 directions, longitudinal 1-1, in plane transverse, 2-2, and through the thickness of the lamina, 3-3. Now we enter the laminate stacking sequence, LSS, comprising the material of each lamina, their orientations, thickness, and ply name. Now, we assign the section to a region. Now we assign the part to an independent assembly. Even if there is only one part, we have to do it. As usual, we need a step for the load, which in this case is a change in temperature. In step load, we start with the boundary conditions. We discretize only 1/4 of the plate, with symmetry boundary conditions on the left and bottom edges of the model. Then, we clamp the origin, to eliminate the possibility of rigid body motion along the Z direction. Next, we add the predefined temperature field. We specify the reference temperature for the initial step, then we modify the value for step 1. Thus we apply a delta T to the region selected. Now we mesh. Element type, quadratic, 5 degrees of freedom because it is a flat plate. Element name, S8R5. As usual, we need a job. When completed, click Results. Since the laminate is a 090, not symmetric with respect to the middle surface, when the temperature changes, one lamina shrinks more than the other, and the plate deforms to the shape of a horse saddle. Since we modeled only 1/4 of the plate, we don't see the deformation clearly, but, as long as there is symmetry, we can use the mirror feature to visualize the whole plate, by mirroring the results we have, on the regions that we did not discretize. Okay, that's it for today. If you liked this video, don't forget to subscribe. You can find more details in the textbook, by following the link in the description. Thank you.